So we are going to be solving for missing side lengths in similar triangles today. I'm going to be starting with some more basic examples and we'll get into some more complicated ones towards the end of class. So we have these two triangles here that are similar to each other, and in geometry that means they are the same shape, but they clearly are different in size. And what you want to do first when you're solving is set up a proportion. So the sides that I'm identifying as corresponding, meaning they are matching up, is the two hypotenuses in this case, which is 17 and x. And they also gave us the bottom of the triangles 8 and 6. And so I'm going to set up a proportion with those involved. As I said in my previous video, there are many ways to set up a proportion, but I'm just going to go ahead and do it as I kind of see it. I see 17 over 8, so that's putting a green side over a blue side, and that should be proportional to the green side over the blue side in the smaller triangle as well. And now we have an equation with an unknown variable x that we can solve for. Now, whenever you have two fractions equal to each other, especially when you're trying to solve for x in this case, it's recommended to cross multiply so that you don't have to deal with fractions anymore. And so what we're going to do is multiply 17 and 6 together on one side of the equal sign. We're going to bring the equal sign down and then multiply the other two by each other, 8 and x. Now I have this convenient little equation with no fractions involved anymore, which makes everybody happier usually. And so we'll just simplify from here. We have 17 times 6 is 102, and that's equal to 8x on the right side. And I almost have x by itself. I just have to get rid of that 8 in the front. And to undo 8 times x, I'm going to do the opposite. So I'm going to divide both sides by 8. Those cross off. We get 12.75 is equal to x. And then just kind of verify with the diagram that that sort of makes sense. Yeah, this looks like it could be about 12 or so comparing to this one over here. Okay, so this problem says that triangle ABC is similar to triangle XYZ. And so I'm going to kind of, because these look a little bit rotated, so I want to double check that I'm doing this correctly. So we have ABC, so A to B to C is similar to XYZ in this order. So X starts in the bottom right, then to Y, then to Z. If that's a little bit hard for you to visualize the comparison, I would highly recommend redrawing one of them. Let's redraw the smaller triangle just because it's smaller, it'll be easier to redraw. And let's make it match up so it's exactly the same direction and not rotated as ABC. And so I'm going to put this in the same order, X, Y, Z. And if you're redrawing it, I would recommend taking some careful time to make sure that you're labeling it appropriately. So obviously angle X is this 75-degree angle. And then it says that XY is 10, so 10 is going to go right here, and XZ is this other variable X down here. And this is the variable that we need to solve for X. And so it might be a little more clear now what sides are corresponding. So I have AB is corresponding with XY and AC corresponding with XZ. And I'm going to use that to set up my proportion. So I'll just do 15 over 21 since that's how they are labeled, 15 over 21. And that is going to be equal to 10 over x. We have these nice little fractions here. We're going to go ahead and cross multiply. Bring that equal sign down and multiply across. We're going to do 21 times 10, which is 210, and 15 times x, which is 15x. And now we have this nice little equation where all we have to do is divide both sides by 15 to solve for x. And 210 divided by 15 is 14. Okay, so let's take a look at these. It says to solve for x here, and it's not even that clear that I am going to be using the same strategy. I actually do have two different triangles here. I have this smaller, darker blue triangle, and actually from A to D to E around the outside is a larger triangle too. Now these triangles are similar to each other because these two lines are parallel to each other. I have them sharing angle A, the big triangle and the small one, and then also these angles, because of those parallel lines, are also the same size, and so is these two angles in the bottom right here. And so because of this, the two triangles are similar to each other, and we can set up a proportion. And the neat thing is this actually does work if we set up a proportion with the sides that we see. I know that this large triangle actually has a side length of 18 plus 4, but the proportion does work actually if we just do 18 over 4 and make that equal to the two sides on the right, which is x over 3. So we're going to start cross multiplying to solve. We'll bring that equal sign down. We'll do 18 times 54 and 4 times x, 4x. Divide both sides by 4, 13.5 for x. And again, we can look at that diagram, and that does seem reasonable that that would be about 13.5 compared to the other values there. Let's do a more complicated one. So just like the last one, these sides are these triangles are similar to each other, and we can set up a proportion in the same way. The difference is I have this little expression right here that might make things seem a little bit more challenging. So I'm going to go ahead and do 15 over 10 is equal to 12 over x plus 2. Just because the problems get a little more complicated doesn't mean our strategies and our problem solving isn't the same. And so I'm going to go ahead and cross multiply by bringing that equal sign down, and we'll do 10 times 12, which is 120. And then now I'm going to multiply 15 times this whole expression, x plus 2. I'm going to write it out just so it's clear that sometimes people accidentally only multiply the 15 times x, but we want to multiply it by the whole expression. So we're going to have to distribute this 15 to simplify this further. 15x, and then 15 times 2 gives me 30. And then now this is a little bit more complicated to solve, but still want to think back to your solving strategies. We want to get x alone on one side of the equal sign, and we want to get rid of these other values. And so I'm going to go ahead and get rid of this addition of 30. So I'm going to subtract it from both sides to cancel it. And we will get 90 equals 15x. And now we'll divide both sides by 15. And 90 divided by 15, I believe, is 6. And there we have that x is 6. So I'm going to do a few more challenge problems in the next video, so be sure to watch that one as well.